able to see it, and I can still see your chat. And we begin with the revision. So I'll show you what is expected of you during the quiz and the exams. So I will do the following topics depending on how much time I have and whether it makes sense or not. So the first topic I will go through is orthogonality. And in orthogonality, of course, you know that if I have a vector A and B and it belongs to Rn, then when is A orthogonal to B? And of course, you by now know that if A dot B is 0, then A and B are orthogonal. And you also know that we can calculate many ways of A dot B. You think of it as, for example, if A is equals to A1, A2, and A3, and B is equals to B1, B2, and B3, then A dot B is equals to A1, B1 plus A2, B2 plus A3, B3. And you can write it in a few forms. You can write it as summation AI, BI, I equals to 1 to n. You can write it as B transpose A. And for real, this is also equals to A transpose B. You must be very careful when it is complex. All right, now, but once you understand this basic, then the questions will be more tricky, right? So the question will look like this. Some of the question will look like this. Which vector is orthogonal to, and I give you some vectors, 1, 2, 3, and then I give you some choices. W1 is equals to -1, -1, 1. And then second choice, I give you W2 equals to 1, 1, -1. Third choice, I give you -2, 4, -2. And the fourth choice, I give you And to answer this question, of course, for each vector, you have to calculate the inner product, and then the answer, the selection key, the answer key that will be asked of you will be things like only 1 and 2, for example. Only 2 and 3. Only 1, 2, and 3. All choices are okay. So you have to be very careful. You look at this and it says -1, -1, 1 is of course orthogonal to this one, right? So I'll just do a simple one first for you. So W1 transpose, let's call this vector. Let's say U. And then you work it out. So -1 times 1 is 1 -2 -3 plus 3, 0. And you have to work out all of them. And then you also realize that the second one is also 0. And the third one is also right, -2, -5, -2, 6, 8, 0, right? Not equals to 0. So the only correct answer is this one. So don't choose the first one, right? Because the question will ask you to choose the most, right? Because here's only. So this is the type of questions that, we expect you to be able to do. So the choices, many choices are given, and the answer key will ask you to choose among all these choices. So this will test you that you now visualize that orthogonality spans many, is a vector belonging to a space. Okay, that's what we are hoping you to understand. Right, this another type of question in orthogonality is this. And this is even more tricky. Given V is equals to 0, 1, W equals to C half. C belongs to the real. Then answer this. Find C for angle between V and W equals to 1 radian. So, so, so this is a non, what do you call that? These kind of questions are non-standard, right? Normally, I give you two real values vectors, and then you go and figure it out. So this question reverse the order of your thinking. Oh, so let's revise now. So remember that we have V dot W is the dot product of V and W is equals to the norm of V, the norm of W cosine theta. So we are asked to find theta such that theta is equals to 1 radian. We are given V. There's no problem. All the elements are here. W, the C is not given. So we cannot really calculate norm of W, but let's push on. Theta is given. So actually we have one unknown here and one unknown here. So the question is non-standard, right? Not trivial to, or not so easy, but let's see what we can do. All right, V dot W by now, we know that it's 0, 1 dot with C and half. And by now we also know, and in the first question, we know that it is nothing but this guy, right? The elements are multiplied with each other and sum. This dot product. Right, so this is nothing but, then interestingly, 0 times C is 0, of course. So where the dot product is trivial now, half. Is 1 times half is half. So on the left-hand side. The norm of V, of course, you know, because it is the length of V, and this is a unit length vector, right? 0 square plus 1 square root is 1. So this is 1. And here is a little bit more complicated. Plus, then here we want to do norm of W. So it's C squared plus half squared square root. So this guy is the norm of W. This guy is the norm of V. This guy is V dot W. So all this guy, cosine, theta is 1 radian. So now it's not so bad because you have everything is known except C, and if you work it out, C squared, okay, or then I will just tell you the answer. Please go and try it by yourself. C equals to 0.778. Finish. Now, when you see this question, and if you work it out only algebraically, it is possible, but it's not so intuitive. So let me, there's a question by Lo. Lo asked whether irrational numbers is 3 decimal point. Yeah, 3 decimal points good enough. Yeah, more than enough, 3 decimal point. Anyway, it's all MCQ, so you're choosing the decimal points, right? I mean, you're choosing from the answers. Okay, Lo? All right, let's try. Now, so I would advise you to, of course, to be able to solve it algebraically, but let us see how to do this geometrically. Okay, so I'm going to plot the vector v and w, and then let's then answer the question intuitively. V is equals to 0, 1. W is equals to C and half. So I'm going to draw it this way. So 0, 1 is here. W is C along the, okay, so sorry, this is V. So V is the blue guys sticking up, 0, 1. And C is along the value horizontal axis by C. Let's assume it's positive first because actually it can be negative as well. And it is half. So half is here. So I'm going to draw a dashed line here. So in fact, then C can be any value, right? Along the horizontal axis. But 1 radian, how much is 1 radian? It is about there, I think. So let's have some C here. And of course, C can move anywhere. And this is theta. So once you figure this out, this is a much easier way to visualize the problem. We are asking the problem of, let us find C, and this is half here. So this point is C and half equals to W. So I should use the orange for this guy. So W is the orange vector, blue is the V vector, and so the theta is wrong because it is theta between who, guys? So this is the wrong theta. All right. Theta should be between the vector W and V. Okay. So that's why you must draw the figure. Otherwise, you like what I have just done, you get it wrong. Okay. Between V and W, not between W and the horizontal axis. Now, so if you actually start from this diagram and then do this, then you have less of a problem and less of a chance to make a mistake. Right. So what kind of tricky questions are possible in this case? The first tricky question. So the first question is easy, yeah? Find C between some fixed theta between W and V. The second question is what value? All right, guys. This is then you calculate and then you say that this is one value. What happened if C? So this C is equals to 0.778. What about this guy? Because you can draw it, then you realize that if you use plus C, W2, let's call it W1, is minus 0.778 and half. Also make the same angle, right? So it's not only one answer. In fact, C can be plus and minus. Okay, so you should draw this, and then if there are two answers there, you have to put two answers. You cannot say only 0.778, then you'll be wrong. All right, other questions. What value Anything? I mean, am I clear so far? Anybody? Everybody? Any questions at all? Yes, okay, good. Now, what values of C will result in largest angle between W and V? Anyone, please think, right? In fact, once you can draw this, you don't even need to think. So what do you do? Anybody, please? 0. No, if you move C to 0, then the angle between V and C is 0. So it's not 0. C cannot be 0. When C is 0, it is not the largest angle, it is the smallest angle. In fact, they will be pointing to the same direction. Melvin, okay? Do you know what I mean? I move C towards the, towards 0, and I make the orange vector points to the blue vector. The angle between V and W becomes 0. So what should I do? I go opposite direction. Yes, tends to positive infinity or negative infinity. So there's no one answer. There's two answers here. Okay? So it's just like the previous way. There's two answers. Plus and minus 0.778 makes the same theta. Plus and minus infinity makes how many degrees, guys? As I go to plus infinity, I'm making what theta? Pi 2. Very good. Yep, that's the answer. All right. So these are the, I mean, you realize that 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 C equals to 0 was one of the choice, right? And if you this is the wrong answer, only C tends to positive infinity. Both C tends to positive or negative infinity. Or only C tends to negative infinity. And the correct answer, of course, is okay. Why pi 2? All right. Okay, imagine that even though there's a half, as you stretch this and further away, what will happen, Marvin? Can you see? It tends to pi 2. You'll never reach pi 2. It'll become flat. Yeah. See? So now theta is growing, right, guys? Theta is growing. W as C tends to infinity. And of course, same at the other side. So if I tends to the other negative infinity, the theta is also going towards pi 2. Clear, Marvin? All right, great. So this is tricky, right? The guy who thinks C equals to 0, finish, they just type this and then, you know, the guy who thinks only positive infinity also will get the answer wrong. So no, there's only one right answer. Okay, because it's not only, it can be both positive infinity and negative infinity. All right, I'm done with orthogonality. So now let's start with the second topic, the topic of least squares. So I hope by now you'll be able to understand now what kind of questions we are asking for, and this is not straightforward. It is, you cannot just do one step and you get the answer. You have to maybe at least do 2 or 3 steps, and you have to understand the basics very well. Okay, any requests, guys, before I proceed to the second topic? Double difficulty. 3 decimal point, yes. Lecture PDF. I don't understand. Someone type lecture PDF? Okay, I'll keep this and I'll continue. And I guess practice question is the most important one. So we are practicing now. All right. Okay, least squares. So in least squares, A is a tall matrix. So basically, I tell you that A looks like this. M rows and N columns, M by N matrix, M greater than N. Okay. So of course, you can immediately, if you really, really want to, you can think of this as A1 and A2, right? And there are 3 rows of A. So for example, if you really want to think concretely, 3 by 2 is a tall matrix. All right. And then the questions begin. Which statements are true, false? So for each statement, you have to determine first. So the first statement, AX, let's do it together, guys. AX equals to B always has a solution. So what does the word solution means? Can someone tell me? The solution. I've given you A, the unknown is X, and I will have given you B. So B is of course belongs to R, M or Rn. Yes? If A is M by N, B is R, everybody? M. Very good. M, Ryan? B, for example, is now R3 in this example. M by N. So A is 3 by 2. X is 2 by 1. B must be 3 by 1. So it's Rm. Now, so when I say AX equals to B always has a solution. The word solution, please tell me, what am I asking for? Which is the solution? No, the word always has a solution. So yes, very good. X is the solution. So X is the solution. Does AX equals to B? Is the equality always satisfied? And the answer is, anybody? No. And the why no? Because? Answer is no. You're correct. Because? Because? Yes. 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 Because solution exists only if B belongs to the column space of A. Okay? Because the word is always, right? So that's the tricky question. If I use the word sometimes, then the answer is true. So these questions are non-trivial. You have to understand completely what the word always means, what the word solution means, what is AX equals to B means. It's the equality. All right, let's ask now the second question. Sum B has a solution. Answer? So the first one is not no. So the first answer is false. Huh? The second answer, sum B has a solution. Very good. True, because when B belongs to the column space of A, AX can be equals to B. Possible, huh? Equality. Very good. All right. So now the third question. See, if A has dependent column, dependent, then X hat equals to A transpose A inverse A transpose B cannot be found. True? All right. Because A transpose A inverse does not exist when columns of A are dependent. So the answer here is true. Okay. D. If A has dependent column, X hat, the least square, huh? The least square solution does not exist. True or false? Very good. False. The guys who think that this is true still have to think that this is false. Because why? Because, guys, why? Yes, and this is the correct answer. Because, yes, we still can use A transpose. Yes, correct. We can use the normal equation to solve it. And then this will result in what? And here implies the solution is unique or not unique or not unique. Oh, not unique means infinite. When the columns of A are dependent, the solution is not unique, it's infinite. Okay, so guys, yeah, this least squares is non-trivial, non-trivial. You have to understand everything to answer all these very tricky and esoteric questions. And then you think what will so the questions don't come like this, yeah. The choices are like this, but in the quiz, you are asked to do this only only what A and B are true. Only B and C are true, etc. And then I mean the worst one is uh, none of the above are totally correct. Can you see now? It's very difficult because you have to get everything right, and then you know if you only get partially right, then again you fall into a trap, right? We're testing whether you understand almost a lot of things. Okay, so I repeat how the questions would be like. The questions will give you a standard questions asking you to decide which are true and false. You have to work it out. And then finally, the options are not only one single option. Of course, it can be only, for example, it can be one single option, of course. Only A is true. Right? Only B and C are true. Blah, blah, blah. You have to choose the most correct answer. Okay. Can we push on? Yes? Anybody? Shall we push on? Yes. Good. All right. Least squares. What are the other types of questions? A 110 011 B 111. You'll notice that the numbers we give you are very simple. Yeah, we'll not give you like some fractions or whatever. You're testing your understanding of the theory, not how you can manipulate numbers. Okay, so the standard questions that we'll ask you is always find x hat such that ax hat equals to, you know, ax hat will will have least squares error to approximate b. Okay, so basically we know that this column, this guy is not in the column space of these guys. Therefore, ax will never equals to b. So we're asking you to find the least square solution. That's it. That's the most easy one, right? And this you should take within 1 or 2 minutes to get it done. All right. Then x hat is, Marvin asks, should we assume that there is no solution or we have to check first? I mean, I'll ask you to find x hat. So, I mean, if you use Gaussian elimination, then if you use Gaussian elimination, you realize that this is what inconsistent equation, right? Then you always have to. Already, I tell you this square, so you must be able to do this. Ax equals to b. So the step is always A transpose Ax equals to A transpose b. X is equals to A transpose A inverse A transpose b. And then you find. So to do this, I think it takes you 2-3 minutes because the numbers are very simple. Is that all right, Marvin? Okay? Right. So the next question is, I will ask you, x hat is unique or not unique? Answer, guys? Even without doing this, even without solving this, I already know. Unique or not unique? The answer is unique. Okay. And because the columns of A are independent. So that's why we always give you very simple numbers. We're not going to ask you to, try to find linear combinations. That'll be hard. Okay. Of course, once I've asked you to find x hat, and you have found x hat, I will ask you to find E and the norm of E. And the E is equals to B minus AX hat. So you have to work out this number and this number. And remember, the norm of E is equals to, is a number, is equals to E transpose E square root. All right. Okay, some other questions I'll ask you. What is the projection matrix of A? Anybody? This is less straightforward. But actually, if you know this equation, it's almost there. Anybody? So I'm going to take this equation and let's cut this, right? Oops. Can I copy? Yeah, could copy. Come. Oh, it cannot go across pages. So bad. All right, let's put it back here. Okay, I'm going to write this for you, and then I'll ask you. No. A transpose is not the projection matrix. All right, let's do it. Always start with what you know. Since this is the entire X, okay? Don't be mistaken. So what is AX hat? Nothing but putting A in front of this whole thing. And now, what is a projection matrix? This is B hat, right? AX hat is B hat. So therefore, the projection matrix is this guy. Clear, Joel and Avandano? So this is a trick question, huh? A transpose A minus, no, it should be this one. And of course, if you have given, I've given you A, you can find P, directly. All right, let's draw some figures. This is B. Okay, the B that we are interested in. What is this square? What would I draw for you now? I will say this square is what? Anybody? Please help. What is the square? The square is the surface where, yes, the column space of A. Because I can reach anywhere along this. And what is this guy here? This is the origin. And then, what is AX hat? It is a vector where? What do I draw? Where would this blue point is, yes, very good. This blue point is on the surface of the column space of A. So this guy, this vector is what? This vector is, anybody? This vector is B hat, very good. Or you can write AX hat. And this vector in brown or orange, this guy is who? E. Yes. And I have to draw something here. And that something here is the orthogonality. E is orthogonal to the column space of A. Any columns of A. What is P times B? What does P look like, guys? So this guy is now R, in our example is what? R3. This guy, R3. This guy, how does P look like? What is his matrix? It's a what by what matrix? Anybody? Yes, very good. So this is a 3 by 3. This is a 3 by 1. This guy is 3 by 1. So P is a projection matrix square. What are the properties of P, guys? There are two properties we tell you. Symmetrical. P transpose equals to P. Pn equals to P. Very good. All right. So we are now we are asking you more difficult questions now. Okay, so listen well. I have given you A and I've given you B. And now I say select only one column of A to approximate B. which column would you select to give the least square error? So I repeat the question here. Given A equals to 1, 1, 0, 0, 1, 1, B equals to 1, 1, 1, select only one column of A to approximate B. Which column to select? Result in least error. A, column 1. B, column 2. So this is column 1, this is column 2 of A. C, either column will result in same error. So there's only three choices, A, B, or C. Guys, Marvin says C. Anybody else? Yeah, it's a trick question. Very good. C, very good. Outstanding. Because you realize that the numbers are the same. Therefore, you choose this, the error will happen at the last guy. You choose this column, the error will happen at the top guy. And the errors are the same. Very good. Yeah, so it's not an easy question, of course. But if once you can visualize this, it's not so hard. All right. Now, since you are so good at this, how about doing this? As I choose 2 here, which column will you choose, guys? Column 1 or column 2? I have now changed B to 2, 1, 1. So it will be, or does it matter? I repeat. Yeah, so now it's column what? Which column will I choose? This column 1, or column 2 to approximate B, which has now been changed to 2, 1, 1. Anybody? Hmm? No, you guys got it wrong. Okay, let's repeat. A is now 1, 1, 0, 0, 1, 1. We call this A1. We call the second row A2. A1 is 1, 1, 0, A2 is 0, 1, 1. B is now 2, 1, 1. Do we choose A1 to approximate B, or do we choose A2 to approximate B? A1 or A2? No, of course not A2. No, A1, A1. Right? Yes, it's A1. For sure it's A1. 1, 1, because if I multiply by 2, it'll be 2, 2. So there's one error here. Here, no matter what I do, I can only, solve this. The error is still 2. Clear? Everybody? And I mean, in this very simple example, I don't even need to calculate. Of course, if the exam is going to make more difficult, the numbers are not so straightforward that you can visually see this. Can I explain one more time? Okay. I'll explain one more time. Okay, let's try. A is equals to 1, 1, 0, 0, 1, 1. This guy is A1, this guy is A2. B is now, I'm going to make life easy for you. 10, 1, 1. Now, is this obvious or not so obvious now? Which column of A, okay, I should say only one column to choose to approximate B. So now, if I choose A1, then I'm trying to say project B onto A1, right? Versus project B onto A2. Agree? So I choose who will result in nearer. So this is B using column 1 hat. This is B using column 2 hat. Which one will produce least error, guys? Is this clear? Mahav, do I need to explain this or is clear now? If you see it this way? Not clear. Okay, let's try. I'm only going to select one column of A. So this is one way, huh? Right? I have to find alpha times 110, right? For B1 hat. Agree? I say choose one column, 110. The only thing you could do is to find alpha, right? Draw the diagram again to show. Draw the diagram. Okay. Wait, done. I will do this first. This is clear, Mahav? Okay, how to find alpha, guys? Mahav, how to find alpha? How does projection of B onto A1 look like? What's the equation? Do you remember? It is, can we just think like, okay, right. So Abel is correct. So the answer should be the alpha is B transpose A1, A1 transpose A1. This is alpha times A1. This is A1. B transpose A1, A1 transpose A1 times, agree? So, first is I say I can move only along this axis 110. I'm trying to find a scalar, right? I'm trying to find a scalar. The scalar is this equation, B transpose A1, A1 transpose A1. Yes, it is B dot A1, A1 dot A1. Now I make it clearer again. So this is alpha, this is A1. All right. So now let's find the scalar. What do you think the scalar would be, guys? So 110 times 10, right? Which is what? 11, right? 1 times 10 is 10 plus 1 is 11. So the top is 11. 11. A1 transpose A1? 1, 1, 1, 1. So what's the value? It is square root of? No, it is 2, not oh. Oops. 2, right? And then what? This is alpha, right? This is 1, 1. Oh, this is A1. And the answer is 11 divided by 2. So it is 5.5 times 110. Answer is 5.5, 5.50. Can? So B1 hat is 5.5, 5.50. So I have half explained this guy, right? I have created some errors here. But at least I've explained this guy. Can you see now? A2? Okay, fine. Fine, A2. A2, 0, 1, 1. B, 10, 1, 1. What is alpha A2 going to be? Or beta A2? Of course, again, you say B transpose A2, A2 transpose, sorry, A2 transpose A2. This is beta A2. Answer is, on top is what? 1 times 1, 1 times 1, so it's 2, right? Below is 2, and here is 0, 1, 1, and the answer is 0, 1, 1. So this is equals to B2. Clear? So now, let me ask you, who will you choose? Who approximate this guy better? This guy or this guy? Okay, now you understand, right? The error here is 10. The error here is 4.5 and 4.5. Then you say 4.5 plus 4.5, but it's a square value, right? Whatever value. In fact, right, once I make this, yeah, maybe you have to calculate the error. Yeah. Sometimes if you are really, really sneaky and nasty, we'll make the two error the same. Then it's non-trivial. No matter what you choose, the error is the same. Well, in fact, that was the question before, right? The question was 1, 1, 1. The error is the same. No matter which one you choose, the error is the same. Oh, am I very soft? Am I? Now, is it okay? Am I still talking? Oh, because oh, okay. Now you can hear me, right? Okay. Any comments? Clear now. All right. Tell me how to improve your learning. I mean, I'm receiving feedback now from your uh some feedbacks are saying that I put it in their YouTube and I'm making your watch what advertisement, and some of you think that I'm making money out of it. I'm not making any money out of it. Okay, trust me, not making any money out of it. I mean, I only get like a few thousand views. There will be no money, right? Ken? How do we know the answer at one glance? You can't. You can't. I mean, if the goal, the answers is clear if the numbers are very obvious. But you can try to disable the ads. I can't. I read. I was reading. Yeah, I can't disable ads because it's free, right, guys? I mean, I can dump the entire videos into NTU Learn if that's possible. What about okay, some questions. Let me, I mean, now I just take some time to chit chat with you guys. Some other improvement is I mean, I make all my slides or my videos like only 3 to 5 minutes. Do you all want it to be like more compact, like 10, 20 minutes or even 1 hour video? Or do you like it to be, small parts? Which part of Argon is tested? All parts, eigenvalues is tested. Compact would be good. Okay, more parts. Okay, some of you definitely want more parts and some of you want compact. Okay, so I'm not going to satisfy everybody. Okay. Uh, lesser videos for each playlist. Right, what I'm going to do is this. I will make everything, I will release all the videos into NTU Learn if that's even possible. And then you guys can do whatever you want convenient with it. How's that? Then you don't need to watch videos, watch YouTube anymore. I'll try to do this within the next few days. But you guys will be dumping a few gigs of videos into your hard disk. Huh? All right, DFT, FFT. Okay, right. I am going to do DFT and FFT now. Okay, let's try. Okay, DFT, FFT. So DFT, FFT, DFT only, sorry, and complex numbers. My only advice to you is do the tutorial questions back to back, many ways round. Okay, so the first question I would ask is this. Maybe let's do the easy one first. Evaluate. I mean, every time I ask you to evaluate is the most easy one, okay? Evaluate who? The notation should be E, J, pi, 4. 2 minus J, half. Okay, then, so I'm testing you on everything. One is polar notations, complex exponential notations, dividing by rectangular notations, performing the square root, De Mor's theorem. So I'm testing you 3 things at the same time. So to perform division, and now remember this notation. I'm lazy, so I always write R E J theta to be R. So just a shorthand so that I don't need to write EJ. And of course, by now you know that this basically means this is length is R, and this is theta, and this guy is this point here. It is the radius, the magnitude with this angle theta. This is the real part of Z, and this is the complex part of Z. So revise your notations. All right, now we have this, and then now we have 2 angle pi over 4 for the top. 2 minus J, guys. And then, of course, what is 2 minus J? So you must draw this, okay? The reason why you get this wrong is once the quadrant is not on the first quadrant, most of your guys will get it wrong. 2 is 1, 2 along the real, right? So I'm circling here for you, 2. Now I'm getting my orange minus J, and this is the vector. And therefore, now when I expand this, this is theta. Theta equals to, guys? Theta equals to opposite over adjacent. So it's arctangent. Opposite is, now I know that this is minus 1. Okay, I know it's minus 1. Opposite is minus 1, but I'm going to use 1. Okay, opposite over 2. And the reason is that I already have drawn this, right? And I know that it is a negative angle. Okay, so arctangent. So arctangent, ATAN, half is 0.463. 0.463. Please put a minus there. Okay, wait, this is what I'm trying to tell you. You see, if I use a minus, it's correct. Minus 0.463. If I use only half, it's 0.463. But look, if I have drawn this, then I know that the angle given to me is 0.463. I know that I'm going down, so it is minus 0.463. It is even more difficult if I'm going to the second quadrant or the third quadrant. This is O-level math you have to revise, okay? And yeah, don't get this wrong. Okay, so then the answer is, what about the magnitude? The magnitude in this case is R is equals to, here the word R is equals to square root of 2 square plus 1 square, square root of 5. So this is square root of 5 angle 0 point minus 0 point minus 0.463. Okay, and whole thing grouped together half. Okay, so this becomes 2 over root 5 to bring the numbers out. Angle here is minus, right? So it is pi over 4. Okay, let me bring out the calculator. So it is pi divided by 4 minus 1.25. About 1.25. So now it is here, everything half. And now, so guys, so from next step, please help me. What is the next step going to be? Which theorem? So, and how does the theorem look like? I'm going to use the nth root. Okay? Yeah, very good. So, R angle theta n equals to, so you must memorize this. The Nemo theorem states that, I have already cast it in this form, right? It's trivial now. R 1 over n. Angle, this is non-trivial. What am I going to write here? In this step. Here, this place. Here's theta, here. Very good, Abel. Your n must be very careful, Abel. Please write it this way. Theta plus 2 pi k. Everything divided by n. Now, if you write it like what Abel has done, yeah, you might get it wrong. Okay, Abel? So it is theta plus 2 pi k divided by n. Clear, Abel? Great. All right. Then, I mean, the rest you can solve. I don't need to do this for you. Okay? All right. So this kind of, if it is complex numbers and we're testing you on all the operations, and you have to get all the operations correct before you get the correct answer. Otherwise, you're just guessing the answer. Now, how many answers are there? How many answers? Remember, it's a square root, so I'm expecting 2 answers. And the first answer is using k as 0, so it's theta over n. The other one is k is 1, then it's theta plus 2 pi divided by n. The magnitude is always the same, it's r to the power. So I'll write the answers that you guys can go and check. The answer is 0.945, angle 1.25, n, not all, 0.945, n 1.25 plus 2 pi divided by 2. So you go and work it out. So the 1.25 is theta, and then the rest is, it's very clear. Okay. All right. What do you need to know for DFT? You need to know these 2 equations. The analysis equation, W, sorry, X is equals to W small x. So let's try. X belong to, in fact, X can belong to complex. Please be sure about that. For example, if let's get this and big X belong to complex 4. Actually, normally, the question will use R4, but can be, can be C4. So if this is 4 element, X1, big X2, big X3, and big X4. And the small guy is small x1, small x2, small x3, and small x4. What is this big W? So always do this first. The index here is K. K is equals to 0 to n minus 1. Here, the index is n. N is equals to 0 to n minus 1, which is 3. So this is n minus 1. And n equals to 4 in this example. So you understand this, I mean, this is a simple linear transformation, right? In fact, it's like ax equals to b. Exactly the same, I mean, once you understand this. So the question is, what is W? What is the size, guys? Yeah, 4 by 4. Oh. Now, if this is a 4 by 4 matrix, what kind of elements in it? I mean, if I were to write a number here, this would be against n, and here will be against k. So n is flowing from 0 to 3, and k is flowing from 0 to 3 as well. So it's a 4 by 4 matrix. What are the elements here, guys? What would I write? Yeah, cool. E minus j, 2 pi over big N, kn. So you must get that minus right. If you get the minus wrong, your numbers are off by a conjugate. So you must get this number, and you fill in the blanks, right? You know where n is flowing and where k is flowing. In fact, even if you get this n and k opposite direction, it doesn't matter because the matrix is symmetrical, right? Okay, once you can fill up this number, then let me fill up the number for you. The numbers for 4 by 4 is trivial. 1, 1, 1, 1, 1, 1, 1. The only thing that you might get wrong is here. That's all here, the second row. So the second row looks like this. Minus j, then minus 1 plus j. Once you can get this row right, I'm sure you can get this row right. Minus 1 plus 1 minus 1. And then the second row and the last row is conjugate of each other. So you've done the 4 by 4. Okay? And if you don't know how to do it, just substitute this equation for different k and different n, and for the fixed big N equals to 4. Any questions, guys? So you need to memorize this notation by heart. Any? Okay. All right. If you have understood the analysis equation, let us then just go through what is the synthesis equation. It's the small x. It is, for example, R4, or in fact, it can be C4, and it is 1 over n. That's the key difference, right? Let me use a different ink. It is 1 over n. And the key difference is W, H. And then the next difference is, no, not difference, it's the big X. So I'm highlighting the difference between the synthesis equation and the analysis equation. Can you see? Oh. The analysis equation is big X equals to WX. The synthesis equation is 1 over n WHX. What is WH? The H operator is the complex, conjugate, and transpose. So basically, you will take this matrix, you will transpose it, and you conjugate it. But it's symmetrical. So WH is very easy. Yeah? WH is exactly this matrix with all the minus J becomes plus J. That's it. So I'll write the matrix for you. Equals to 1 over, and we are still playing with n equals to 4. And this is symmetrical. So this is all correct. So now I take the second row. 1 minus J minus 1 plus J become 1 plus J minus 1 minus J. 1 plus, oh, let's do it in a different color so you can see exactly where's the difference. Plus J minus 1 minus J. So this is the key difference. The rest of the value is almost the same. 1 minus 1 plus 1 minus 1. Then the last one is again different. This is minus J plus 1 minus J. And here will become our capital X0, X1, capital X2, capital X3, and here will be our small x. All right, so compare the two matrices, guys. Don't get the matrix wrong. The top one is the analysis, the bottom one is the synthesis. For DFT analysis, how does the negative power of E? Oh, okay, the gentleman asked. Why choose negative, right? Is that your question? Abel? Oh, wait, you are asking me. Okay, yeah, wait. Minus J plus J, plus, plus, plus. Yes. Should. Yeah, okay. I always get my plus and minus wrong because yeah, after a while, they all look the same to me. Okay. Plus one or not? Not zero or what's your comment? Oh, let me see. How does the negative power of J comes out, right? Here, you're talking about this guy? It's a trick question. Huh? Why DFT have such formula? Okay, now you're asking difficult question. Why DFT have such formula? All right. This one, can you see the first? Okay, because this is a revision, I'm not going to do this, but let's compare the first row and the second row. The first row is a complex exponential rotating with omega 0 radian per sample. The second row is the complex exponential rotating at omega equals to pi over 2. The third one is pi over 2 become pi. The fourth one is 1.5 pi. So there is a relationship between each row. They are harmonics of each other. The genius of Fourier is that he's the first guy who thinks that, hey, I can break a signal into complex exponential. Of course, when he did it, he was using sine and cosine. But now we see it as complex exponential. It's much easier to understand. Clear? How's that? Ding? Ding Quang An. Yeah, that's the non-trivial question. Anybody? Ding? Can you hear me still? I'm still talking to myself. Yes. All right, but let's not do all this. I mean, if you want to go there, maybe we'll do advanced linear algebra one day. Okay? All right. And I'm now 1 hour and I've been speaking to myself for 1 hour and 15 minutes now. Okay, I'm going to almost call it a day May I call it a day? Okay, okay, I'll just. You have no idea. This is bad for my throat. Please make the exam. I don't understand. More examples. Can't practice questions for argon. Which part of argon is tested? Argon is tested all. Okay, so I'm going to do argon now. Wow, I've done a lot of linear algebra. Okay, now argon. Harder examples. Yeah, but if the examples become harder, then hmm. Okay. Okay, let's try to have a hard example now. How's that? Oh, 8.3 for quiz 2. Yeah, for quiz 2, yes. But for exams, everything. Huh? Okay, let's do this. So now we are reaching the last topic, eigenvalue and eigenvectors. Hmm. A is equals to 1, 1, 1, 1. B equals to C, 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 C. C belongs to the real. Okay, so now the question to you is, are the eigenvalues of A and B same always? Try. Okay, so they are not always the same. Of course, it's obvious. I mean, if C is 1, then the A and B are the same, then they are the same. If C is not 1, then why are, then maybe the question should be saying, then how? Okay, so are the same always? So answer is, if C equals to 1, A, B equals to same, then eigenvalue vector equals to same. If C not equals to 1, then 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 what, guys? Yeah, so this is non-trivial. Yeah, you have to work it out. All right, let's try. So let's find the more difficult problem first. B is equals to C, 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 C. So to find to find the eigenvalue first, find eigenvalue. So this is the step, right? We first find the eigenvalue. So it's Bx equals to lambda x and x not equals to 0. Bx equals to lambda ix, b minus lambda ix equals to 0, x not equals to 0. Therefore, this is a not invertible matrix, and therefore this one implies the determinant of b minus lambda equals to 0. Therefore, CC minus lambda I means lambda 0. Anytime, please stop me, okay, guys, if my steps are not clear. So this you must do it like, with your eyes closed, right? I made a mistake here. Hmm? What should the number be? Lambda goes out minus 2c. Therefore, lambda equals to. So when c is equals to 1, lambda equals to 2. You can go and verify on the top. Okay, so this is the answer for eigenvalues. So for A, 1, 1, 1, 1, C is equals to 1. Therefore, without calculating the eigenvalues of A, I already know that the eigenvalues of A is 0 and 2. Can you see now? So when this question, right? This question, if you have started with this, right? And then you have to do this, then you are wasting time. You just do B first, and then you can substitute C. Clear? So this is a trick. So now you can answer, are the eigenvalues of A and B the same? Because now, just by this answer, you already can answer. They are the same only when C is the equals to 1, and they are different. One of the eigenvalue is the same. So now the answer, the key question is this: why is lambda equals to 0 mean? Or what does? Anybody? Look at this matrix. C, 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 C. What kind of matrix is this? It has what? It has, guys, what kind of matrix is this? Yes, it has dependent column. And what does dependent column means? Implies singular. Singular means not invertible. Not invertible has many reasons. One of the reasons we find today is what? The determinant is yes. So yes, of course. So you have 10 of them, the invertible matrix theorem. But today we find that what? Lambda. Yes, one of. So if the question is invertible matrix, no, singular matrix not decomposable? The answer is nothing to do with that. Invertibility and invertibility and being decomposable has two different things. But when it is not invertible, for sure one of the eigenvalue is 0. Okay. Now, then I'm going to ask you. So for A, oh, so sorry. A equals to 1, 1, 1, 1. B, now let's do a simple one. what can we say about their eigenvectors? Same? Different? One of them the same? What can we say? The eigenvalues, we already can tell you. One of them is the same. One of them is different. We can even tell you the value. But now, what about the eigenvectors? Anybody? This is my last slide. After this, I'm done. Please participate. One? No, no, no. We're not asking you the eigenvalue now. We are talking about their eigenvectors. Same eigenvector. So our friends say this is the correct answer. Even though they have this different eigenvalue? Yeah, so exciting, isn't it? Yes, correct. Answer is they are the same eigenvectors and we are done. But of course, if you do not know, then you have to work out the eigenvectors of A, the eigenvectors of B, and then you'll find that they are all the same. And the real trick is actually, guys, is to do it in B using all the C's, right? And then you will work it out and you realize that they are the same. So Marvin, why are they the same, right? So the answer is this. You go and solve for the eigenvalues of B, which is what? 0 and 2C, and then you substitute into this matrix and you solve for the eigenvectors. And then you realize that for any C, it's the same. Clear, Marvin? Right. And I am done. So that's it for me. We are just going to stop the recording now and okay. Now we just chit chat for 5 minutes.